In this video, we will learn prime factorization, methods and applications. It is the important mathematical concept. Introduction. First of all, we will understand numbers. Even number, odd numbers, composite number and prime numbers. Even numbers are the numbers which are divisible by 2, and every even numbers ends with 0, 2, 4, 6, 8. Example 2, 4, 6, 8, 10, 28. Odd numbers, the numbers not divisible by 2, and it always ends with 1, 3, 5, 7, 9. Examples are 1, 3, 7, 15, 29. A composite number. A composite number is a natural number greater than that has more than 2 factors. Example 6 is a composite number because it has a factor 1, 2, 3 and 6. Composite numbers are contrast with prime numbers which have exactly 2 factors, 1 and itself numbers. Examples of composite numbers are 4, 6, 8, 9, 10, 12, etc. A prime number. Prime number greater than 1 with only 2 factors, 1 and itself. It's neither even nor odd, rule applied strictly, except 2, the only even prime number, and rather the remaining prime numbers are odd numbers. Examples 2, 3, 5, 7, 11, 13. Here is the list of prime numbers from 1 to 100. There are total 25 such prime numbers from 1 to 100. Here 2, 3, 5, 7, 11, 13, 17, 19, 13, 29, 31, 37, 41 up to 97 are the 25 prime numbers in the range of 1 to 100. The important concept of this presentation is prime factorization. The prime factorization is breaking a number into the product of prime numbers. Basically, prime factorization is the breaking any number into a product of prime numbers. For example, prime factors of 60 are 2, 2, 3, 5. Here we will learn the method to find out the prime factorization. First, we learn division method. In division method, start dividing the number by the smallest prime numbers. Always start from 2, then 3, 5, etc. Continue dividing the result by prime numbers until you reach all prime numbers. List out all prime numbers that were used as a divisor. These are your prime factors. Example 60. 60 is a composite number which can be further divided by 2 and it will be equals to 2 into 30. Again 30 can be divided into further 2 into 15. Again 15 can be further divided 3 into 5. Therefore 60 is a combination of 2 multiplied by 2 multiplied by 3 multiplied by 5, and 2, 2, 3 and 5 are the prime numbers. Further, the 5 and 3 cannot be divided because 2, 3 and 5 are the prime numbers. Therefore, 2, 2, 3 and 5 are the prime factors of the 60. Second method is a vertical division method to find out the prime factorization or prime factorize the numbers. First, write the numbers to factorize. Divide by the smallest prime factor that fits exactly. Write that prime on left. Write the quotient below. Repeat with the quotient. Stop when quotient is 1. All primes on the left are the factors. Example we will study. Here we will factorize number 48. The number 48 we have to factorize it. Again, read the rule number 1. Write the number to factorize. Here we have written number 48. We have to factorize it. Divide by the smallest prime that fits exactly. Here we will understand the 48 number is either even or odd. As 8 is at the unit place, so we can say it is the even number, so it can be divided into 2. Therefore, first we will divide this number by 2. Then the answer will be 24. Again, 24 is the even number and 24 is not a prime number. Therefore, we have to divide this by again a smallest prime number. Here, as it is the smallest prime number and it can be divided into 2, then the answer will be 12. Again, 12 can be further divided into 2 and the answer will be 6. We have to divide this all the numbers on the right side up to the last digit comes to 1. Here it can be again divided into 2 and then the result is 3. Again, 3 is a prime number and 3 can be further divided by 3 and then the result will be 1. Therefore, the numbers appeared on the right side. 2, 2, 2, 2 and 3 are the factors of the 48. This is the prime factorization by vertical division method. Third, factor tree method. Take any number and start by writing the number at the top. Break it into any two factors. They do not have to be prime numbers. If a factor is composite, not a prime, break it down further until all the branches ends with the prime numbers. The numbers at the end of the branches are the prime factors. Here we will take an example 60. Start with the 60, split into 60 into two numbers. Here we will break 60 into 6 into 10 and then 6 again can be ends into 2 into 3 and 10 can be ends into 2 into 5. Therefore, in simple tree diagram, we can see 60 can be split as a 6 into 10. Further, the 6 can be split into 2 into 3 and the 10 can be split into 2 into 5. Applications of prime factorization. It helps in finding LCM and HCF. You can see our video on how to find the LCM and HCF on prime factorization method. It is also used in simplifying the fractions. The method is also used to finding the square root. You can also watch the video on the list given below where you can use the prime factorization to find the square root of any number. Finding the cube root. It is also used to find the cube root of any numbers. By just factorizing the numbers, you can find out the square root and cube root. Thank you for watching.